Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And today's lecture, I'll be discussing single phase full wave controlled rectifier with RLE load. Firstly, what is this RLE load and what is a practical example of this RLE load? And here we will be making use of this RLE load in DC motors. Yes, RLE load is the practical example of a DC motor load where a DC motor comprises of a resistor, inductor as well as back EMF of motor. And firstly, there is a full wave controlled rectifier with RLE load. That is, it basically converts AC to DC, where input is alternating in nature, where it has got both positive half cycle as well as negative half cycle. So, during the positive half cycle, the polarities across the input are positive, negative, as well as positive, negative. When anode is more positive with respect to cathode, T1 is forward bias. Similarly, when cathode is more positive when compared to anode, T2 is also forward bias. The moment when T1, T2 are forward bias, we can provide a triggering pulse such that it starts conducting. So here, since we are making use of RLE load, here we have taken E as a reference. So when E is greater than Vs, at that instant, thyristors will be in the reverse bias position. That is, cathode of the thyristor will be more positive with respect to anode. That is the reason here T1 and T2 does not conduct. And the moment when Vs is equal to E, at that instant, what happens? Let us see. Vs is equal to, let me write it as Vm sin omega t, which is equal to E. And the instant when Vs is equal to E, let me call this instant as theta 1. So here I am substituting omega t is equal to theta 1. Vm sin theta 1 is equal to E. In that case, E1 is equal to sine inverse of E by Vm. Sine inverse of E by Vm. So at this instant, there is the minimum triggering angle required in order to fire the thyristors. Otherwise, thyristors will not conduct. So this is the condition which need to be satisfied. And by exceeding theta itself, by exceeding alpha greater than theta, only then thyristor will come into the conduction state in RLE load. So here, whenever alpha is made greater when compared to that of this minimum angle called theta 1, only then thyristor starts conducting. So this is theta and this is that alpha, where alpha should be greater than theta 1. Only in that case it starts conducting. So here at this instant, when we provide the triggering pulse during the positive half cycle, at that instant thyristors T1 and T2, since they are forward bias, and it starts conducting current through the load. So this is E, and beyond which when alpha is made greater than theta 1, thyristor T1 and T2 started conduction, and it has conducted from alpha to pi. And at this instant, since it is RLE load which has got inductor in it, so that is the reason initially the polarities across the inductor will be positive and negative, and because of which when thyristor 1 and 2 are conducting, see, thyristor 1 got short circuited, similarly thyristor 2 got short circuited during the positive half cycle. Since T1 and T2 are conducting, it conducts current through the load in this direction through T2 and back to supply. This is the flow of current during the positive half cycle when T1 and T2 are conducting a current through the load, and during which inductor is charging, inductor is actually charging, and here that is how Vs is equal to V0. Whatever the supply voltage which we have feeded will be appearing across the load from this instant called alpha to pi, and the moment it reaches pi, whatever the energy stored in the inductor, the polarities across the inductor will change, and by the time it is completely charged, the polarities across the inductor will be changed. It becomes negative and positive. According to Lenz's law, it tends to allow the current in the same direction. So that is the reason it will change the polarities, and since anode of the thyristor is still positive, even the negative half cycle has been appeared. Because of this polarity, inductor is still maintaining T1 and T2 in conduction even during the negative half cycle. That is how T1 and T2 are conducting a current through the load right from this instant called pi to pi plus alpha. And again at this instant called, the thyristor is getting turned off. That is, we call it this instant as beta, and again E at this instant called pi plus alpha, we are again providing triggering pulse. That is, negative half cycle has been appeared, and the polarities across the supply is negative and positive, and because of which T3 is forward bias as well as T4 is forward bias, and because of which the current flow through the circuit will be like this. T3 current will be flowing through the load in the same direction even during the negative half cycle because of T3, and again T4 and back to supply. And at this instant called pi plus alpha, since T3 and T4 are conducting a current through the load, T3 and T4 are conducting current through the load, and at this instant called 2 pi, this inductor is still maintaining T3 and T4 in conduction, and that is how whatever the energy stored in the inductor will be dissipated through the load through these thyristors T3 and T4. That is how continuity of the current flow is maintained even during the negative half cycle. So we are getting the negative spike right from this instant 2 pi till beta, and again E, and positive half cycle, the cycle repeats. And let us connect this to the back end, and we get the negative spike over here. We never know when the waveform starts, and that is the reason we are connecting this waveform to the back end. And here during the positive half cycle, thyristor T1 and T2 are conducting, T1 and T2 are conducting. That is how we are getting output voltage, and whatever the supply voltage which we are actually feeding will be appeared across the load. And again during the negative half cycle, T3 and T4 are conducting a current through the load, and again T1, T2. And coming to the output current, see, when thyristor 1 and 2 are conducting, at this instant current started building. See, thyristor 1 started conducting the current through the load. So it started at this instant called alpha, current started building through the load, and it becomes maximum at this instant called pi. And if you observe here, current through the load is building at a slow rate because of the presence of the inductor in the load, and that is how current is building at a slow rate and becoming maximum at this instant called pi. Once it reaches pi, whatever the energy stored in the inductor is what providing energy through the load. So since inductor is dissipating current through the load, whatever the energy stored in the inductor is getting depleted. So that is how after maximum, current through the load is decreasing and becomes zero at this instant called beta. And again at this instant called T3, T4, thyristor T3 and T4, since it is conducting a current through the load, current started building, becoming maximum at 2 pi, and further conducting till beta because of the presence of the inductor, and it is becoming 0, and again T1 and T2 is conducting the current through the load. And this is what the output current through the load, output current waveform looks like this. After this, we will see the voltage across thyristor 1 and 2. So, the voltage across thyristor 1 and 2, the voltage across the thyristor appears during the off state. So, during the off state of the device, whatever the voltage across the supply will be appeared across the device during its off state. On state voltage will be very less, it is almost equal to 0, and the off state voltage during the off state of the device, whatever the input voltage which we are applying will be appeared across the device. And that is how, if you see here, since this is E load, see whatever the supply voltage is appeared across the thyristor during its off state, and now thyristor T1, T2 came into the conduction state. So what the voltage across the device is becoming 0, and it is maintained 0 till the instant where the thyristor is actually conducting, and at this instant the voltage across the thyristor is becoming 0. And later, since thyristor T1 and T2 are turned off at this instant, it will be following the supply voltage, and that is how we are getting the output voltage right from here till the instant where T1 and T2 is conducting. So this is the voltage across the thyristor 1 as well as 2. In the next lecture, we will be seeing single phase full wave midpoint rectifier with resistive load. Thank you.